Yes. Let us start. Let us show you certain um, the manuals of certain universities of repute whose different strength of material labs is given here. I can discuss with all these present with our present ones so that it can give you certain impression what the others also doing the same or differently. This is first of all the brilliant hardness testing machine which we have covered few days back and few weeks back. What is the apparatus they are using is same brilliant hardness machine and specimen of mild steel. They have mild steel, cast iron, and non-ferrous, some other non-ferrous metals, where maybe possibly the copper itself and a Brinell microscope. So we are also using the specimen of mild steel, but not exact, but it is properly hardening. It is case hardened mild steel and copper as well as aluminium, but they are doing cast iron and other non-ferrous materials, and they are also using the Brinell microscope itself. Now, what is the theory of hardness? I've told you a number of times. What do you mean by the hardness? Hardness represents the resistance of material surface to abrasion itself. Resistance to of the surface of a resistance of the material surface to abrasion, scratching, and cutting means it is the property with which we did a particular material resist the abrasion. Means abrasion means rubbing with other surface, other harder or softer surfaces without damaging himself, and scratching by means of a hard tool, hard pointer, whatever it may be. It resists the scratching over the surface, and if you machine it by means of tool, it creates the resistance against the cutting itself. So all these three properties are defined as the hardness itself. The hardness can gives us a clear indication not only the how hard the material is, in how resistant it is to the abrasion or scribing it, but also the clearly indication of strength, how strong the material is. Means what is this tensile or what is this magnetic strength, etc. In all hardness tests, a definite force is mechanically applied to this space about 15 seconds. So what we have seen here in our presses also, with a force of known value is applied directly to the test piece but through the indenter, say around 15 seconds, 10 seconds, or like this. The indenter actually that transmits the load to the harness. Indenter actually transmits the load to the harness, uh, the load to the test piece itself varies in size and size for different use. So what we are having a force which is mechanically applied to the workpiece through a indenter, which goes the load to the test piece itself, which transmits the load to the test piece itself. This indenter may be vary in size and shapes for different tests itself, and as per our own requirement, we have to make our we are make it accordingly. But most common indenters are made of hardened steel or diamond, which is itself the hardest material as it is existing material itself. Now, in real hardness testing machines, balls still you use steel balls are used as the indenter. Diameter of the indenter, diam, diameter of the indenter and the applied force applied upon the thickness of the test specimen. Because of the accurate results, and depth of the indentation should be around less than one tenth of the thickness of the test piece itself. So what we are finding from here that we are which is tallies with our present machine. We are also using steel ball pieces of 1 centimeter and half centimeter thick, diameter, which is polished and hardened, and they are also using as the indenter. And this force applied force of will depend upon the thickness of the test specimen. What uh, we have the different test specimens of the Brindle, Rockwell, and Vickers machine. Brindle practice has a square blocks of thickness at least 2.5 centimeter, where for the steel or for the aluminium or for the A itself, for the steel it is square, and for the copper and aluminium it is round, but of thickness is more or less same, around 2.5 centimeter itself or 25 millimeter itself, where we have the the length is around 150 square or so, or diameter is around 150 millimeters diameter or so. This is the size of the workpiece used in indenter as workpiece in a real hardness machine. But in case of Rockwell and Vickers, we are having a thickness of around 1 centimeter or 0.8 centimeter, and diameter around 8 8 centimeter or 9 centimeter or so. This is because depends on this is because of this seasonism. Because of the accurate result, depth of the degradation should be less than one-eighth of the thickness of the text pieces. So, depth of as we are using much higher load in brittle hardness from starting from 750 millimeter, 500 kg to 3000 kg, impression is supposed to be more deeper than the Rockwell or Vickers machine because they are using only 60 to 150 and from 5 to 25 to 50 respectively 50 kg respectively itself, where real uses the highest load starting from 500 kg and finishing to 3000 kg as far in our own machine equivalent load they are producing like this, and for our machine it is 500 to 3000 kg equivalent load itself. So that's why we are using much bigger and thicker material for Brinell, so that depth of impression should be less than one-eighth of the thickness of the material. If the thickness is 25 millimeter, it should be aromatic depth can be mostly 3 millimeter or so. So impression, as we are applying higher load, the depth of the impression is supposed to be more. So we have to make bigger and thicker blocks to accommodate this higher load to give a accurate result itself. Now, accordingly, to the thickness of the test piece increase, the diameter of the indenter and force are being changed here. Now, what happens here? Uh, if we increase the thickness, the diameter you can use higher diameter of the indenter, and force can be used at higher force. So if you see for 10 centimeter or 10 millimeter or 1 centimeter ball, we can use as load as high as 3000 kgs, 3000 kg itself. So this satisfy our tallies with our own findings itself. Now, what will be the specification supposed to be the machine? Specification means what is the dimension and capacity of the machine itself. Of any type of machine, this term specification applies, which means how much work it can be do, or for any machine, how much for this taking machine, what is the biggest amount of material or the hardest amount of hardest material which we can check in this type of machine. This gives us the specification itself and how much here. So the specification hardness and content of Brinell machine, Rockwell or Vickers. Specimen may be a cylinder, which we have seen a V-shaped holding device, which you can put inside the cavity of the platform of the load carrying platform itself by lifting, keeping the load carrying platform out and putting the specimen inside it. And specimen may be cylindrical, cube, thick and thin material sheet. A Brinell Rockwell hardness test machine gives machine along with the specimen shown in figure below. Here I'll go to the figure. Yes. Now the specifications of their machines are accordingly ability to determine hardness up to 500 billion hardness number. As per our the chart goes, they gives us around more or less same real hardness number as the specification itself. The diameter both they are using minimum as 2.5 millimeter, where we can use the minimum diameter 5 and maximum diameter 10 millimeter itself. The maximum application load they are given is 3000 kg itself, and method of load application is here for according to just like us is also lever type. The capacity of testing the lower hardness range is 1 BHN application of 0.5 d square load, means 1 real hardness number on application of 0.5 decrease load, which is too less, which we cannot do in our machine. So what they are doing in the calculation in their what? First, insert the ball of the die in the ball holder of the machine itself. Make the specimen surface clean again by moving all the dust, rust, and oil and grease, etc. Make the contact between the specimen surface and the ball by rotating the jack adjusting wheel. So here you also moving moving up the specimen surface, specimen kept over the platform itself, and touch and contact it with the ball by rotating the jack handle reverse. Push the required button for loading. We don't have any such cases, but we have. They have somehow. I don't know. They have how. What is their function? Then use the load release valve and wait for minimum 60 seconds. The load release rod level, you apply it, we move it at right side with 10 to 15 seconds. Load will be automatically applied gradually. And so it will have 20 to 15 seconds duration is required so that load will apply and remain inside the machine itself. Remove the specimen then from the support table and locate the indentation, find out the locate the particular indentation we have made this time so far, and view the indentation through the microscope and measure the diameter small d by the diameter micrometer fitted microscope. Microscope has inbuilt diameter which is carrying of accuracy 0.01 millimeter, with which you can measure the diameter d of the impression itself. Then repeat the entire operation 3 times. We made general 2 to 3 times, and with the same material, and we do it in different materials and different places to we have made this impression accordingly. What is the observation itself? It tallies at our own observation. The following observations are recorded. What they are supposed to do? What is the ball diameter here? And what is the exactly applied load here? What is the diameter of the impression we have measured? And what is P by D square? And what is the mineral hardness which we are available from the mineral hardness chart itself? PHN, the load applied divided by the spherical surface area indentation is there. They are possibly not using mineral hardness, but they are directly utilizing the equation which I have shown you after earlier. This is equal to 2p divided by pi d, capital D minus root over square root of d minus small d, where p is the load applied, capital D is the diameter of the ball impression, ball for indenter ball, and small d is the diameter of the impression created by the ball itself. Now, the specimen, what is the required precautions we are supposed to take? The specimen should be cleaned very properly everywhere. This is the most required and likely if possible. You can use chemical to clear all the scales and dirty marking and other uneven marking. Next, make reading board carefully and correctly. Take reading as quick as possible so that because we have by using the Brilliant microscope, it requires practice to make the right type of impression, to make the first search the impression and then measure the right size of the impression itself. Because over the measurement of this diameter, small d, your calculation, importance of your calculation, I mean the accuracy of your calculation is desired. Now, place the specimen properly, which means they are also saying that specimen is supposed to be placed inside the just at the center of the machine, not at the side, and specimen impression should be take more or less at the center of the machine itself. After the impression, all the work is complete, it is to be grinded to finish. It's again make it exit perfectly flat. And jack and wheel alignment should be moved slowly, not in a hurry. We should move and just touch the applying load, touch the indenter itself before this movement should be stopped. Then after applying the load, after certain time, say 10 seconds, 15 seconds, or 20 seconds, you will slowly remove the load itself. Now, what are the limitations? There are certain Viva questions. Just 1 second. What is the question available in Viva itself? What is the limitation of brilliant hardness test and why? What can be the answer? The limitation of brilliant hardness test is you cannot use a load below a certain limit. So you cannot check a thin piece of material with this type of processes, because It requires higher load, it requires higher diameter impression, and it creates bigger impression, and thus it will not possible to use the workpiece, I mean test the workpiece which is thin inside. It must be thick. That is the most important limitation of brittle hardness. But it is unlike Rockwell and unlike Vickers, especially for Vickers, where you can use as low as 5 kg load even. Where in Rockwell you can go as low as 60 kg, but in impression in Brittle, we can minimum load at least 500 kg, not less than that, in our machine at least. And generally all other machines more or less follow this thing for their work itself. Next is which is the hardest material and why? We know for engineering practices, the diamond is the hardest material which exists in the earth itself. There are others there, but diamond is the hardest, and the diamonds which you are using, it is important and precise and precision and costly because of its application, but it don't have any ornamental value. It is not worth a few lakhs, only a few rupees is required for this black workable diamond itself, which is extremely usable and requires high degree of skill is required to make the particular type of shape to the diamond itself. That is the most important part, and you have to fix it in the other side of the impression itself, which is much less, hardness is much less than the diamond. So we have to fix it properly so that diamond itself during the type process should not break it properly. Now, can we break it the tensile strength of a material if its hardness is known? Question is, we are measuring the hardness means ability to resist the material, resist the ability to resist indentation or impression in the of the material itself. But when we predict the tensile stress, what we are going is the force per unit area we are applying it, and this force what we are applying is a compressive force itself. Oh, so what we have defined and the cross-sectional area is given, it is a compressive force per unit area applied to the material itself. But we require whether you can predict the tensile test. Yes, we can do, because mostly we are using using this ductile material whose tensile strength is more or less equal to the compressive strength itself. So we can say the compressive strength is equal to the tensile strength of the particular workpiece itself. So what is the brittle hardness number? It is kg per square millimeter. It is which is the area of the hardness, which area of the thickness itself, which ball is recommended for brittle test. Generally, we recommend for 2.5, 5, and 10 millimeter diameter ball for brittle test, and not less than that. Let us study the Rockwell hardness here, what they have done and what they are machine, what the theory they have produced. Just 1 second. To study the Rockwell hardness testing machine and to perform the Rockwell hardness test, what is that? What is the apparatus they are using? Only Rockwell hardness testing machine, and they have specimen, mild steel, and other materials. It's not written properly. Possibly they are using aluminum and copper also. Generally, these are the standard materials which we are using here. Again, what is the theory of hardness itself? Again, the theory is same: resistance of the material surface to abrasion, scratching, and cutting, etc. Hardness of giving clear indication of strength in it is both tensile and compressive strength, and all hardness tests, a definite force is mechanically applied on the piece, varied in size and shape for different tests. Common indenters are made of hardened steel or diamond. Here, also, although the indenters are different, but the same process is going on. A definite force and compressive force is mechanically applied on the piece itself, where this piece will be varies of size and shape for different type of tests, and common indenters are made. It's made either of hardened steel or diamond. Here we are using diamond indenter, where we in brittle we are not using the same. And here also is the same thing, that thickness of the workpiece should be at least should not be such that it should the impression should be 1/8 of the, at least at most 1/8 of the thickness, not less than that, not more than that. So accordingly, thickness we have to measure, we have to make accordingly. Now, this Rockwell hardness tester presents direct reading of hardness number on a dial. Direct reading of hardness number on a dial provided with the machine. Principally, this test is similar to Brinell hardness test. So it is doing the same thing. It is creating impression, and but it is giving a hardness number directly from the machine itself. Unlike we don't have to consult any chart or don't have to make any calculation or ready calculation to know the hardness itself. It differs only from Brinell and Brinell is the diameter and material of the indenter itself and the applied force itself. Here we are having the 1 by 1/16 diameter small hardened steel ball and 1 by 1/16 square diamond impression in our machine, and more or less their uses the same because and they are applying the applied force is also much less than the brittle hardness itself. There are many scales having different combination of load and size of the indenter, but commonly C scale is used, and hardness is presented as HRC. C scale, যদি prefer, there is C, we have shown you C, and as well as a red scale and black scale. Both these two scales are used, either R or C, and mostly we are using C scale, and hardness presented HRC or only RC, Rockwell scale. Here the indenter diamond cone at the tip and applied force is as high as 150, same with us, and soft materials are tested in B scale or red scale with a 1.6 millimeter diameter, slightly less than more than that. Then our diameter is 0.16 millimeter and steel indenter of 60 kg. So here also using minimum load as 60 and maximum load as 150 kg here as per our own record. Now, what can be the specification of the diamond testing machine? Again, I'm telling you, specification means what will be the size of the machine and what can be the maximum size of the work which you can accommodate and do. Here we are making the testing of the hardness of it. Here that our change is what will be the maximum size of the workpiece which can accommodate in this machine, and what is the maximum type of load and maximum size of indenter you can use this type of machine. These are the specification of Vickers as well as the Rockwell as well as Brinell machine. So what we are doing here, we can this machine or Vickers machine specimen may be a cylindrical, maybe cube, thick or thin material. Here we can use thick, all right, I referred, but we can use thin, unlike Brinell hardness test. A Brinell cum Rockwell hardness testing machine used along with the specimen is shown in the figure here. What is given in this scale? The scales is given A, B, and C. Three scales are there coordinated. For the type of indenter, we can use cone 120, which is diamond cone of initiate angle is 120, and ball 158 of 158 steel ball of diameter 1.58, and cone again diamond is 120 degree. So here save this diamond cone of 120 degree apex angle and diamond cone of 100 degree apex angle used for B, for C and A. We have used only B and C scale. So here we have used only ball of around 1.6 millimeter and cone is around 120 degree itself. The initial load means before applying the indenter load itself, we have to apply a certain amount of load to move the dial of the machine itself to get an initial reading of the dial itself. That initial load is generally 10 kg for all the cases, and so for major load for this diamond cone is 50 kg, and later load for that is 140 kg, and for B scale for ball load is 90 kg the major load. Pointer position is always 0, and here the pointer position for this ball is 30 degree itself. So kind of material is cone 100 degrees with 50 kg load, much harder, such as carburized steel, cemented carbide, etc. This type of extremely hard material are being tested with 50 kg load and with diamond cone 100 kg and with scale A, which we don't have in our machine. And here the comparatively softer steel, copper, aluminium, brass, gray iron are used with ball size of 1.6 and around and weight around 90 or 100 kg major load. And diamond core for 120 degrees is also used for 100 with 180 loads and 10 millimeter initial load, where to test the hardness, hard steel, tungsten, molybdenum, VM, etc. like this. So what will be the procedure? First of all, you have to insert the ball of diameter D in the ball holder. We have known the ball diameter should be known to you because it is extremely small. It cannot measure it in a normal or convenient way. Next, make the specimen surface clean by removing dust, dirt, oil, and grease. So again, the same thing we are doing. They are saying, use the specimen with by removing the dirt and oil and grease, etc. Now, make contact between the specimen surface and the ball by rotating the jack adjusting wheel. So make the contact between the surface and the ball by the jack adjusting wheel means we are moving clockwise direction so that the surface of the specimen platform of the specimen and along with the specimen goes up and and it will engage with the indenter itself. But unlike push the required button for loading, and unlike the Brindle and Vickers test, we put the load release lever, wait for minimum 60 seconds. But here we will move up the specimen to make an initial reading over the specimen itself, which we have shown here. Here then load release lever will wait for 15 seconds. The load will automatically apply gradually itself. Then remove the specimen, withdraw specimen, and see the final position of the indenter itself. There is so many details is not given here for this machine, and then repeat the entire operation and locate the indentation so made and repeat the entire operation again 3 or 4 times. So following observations we are supposed to make recorded from a test or steel specimen as using a hardened steel ball as indenter. So different specimen we can test, same specimen we can use Rockwell A, B, and C, and use the load 100, 130, 100, so and so, and with divided by T the depth of thickness divided by 0.002. So what is the precaution? The specimen should be clean and making reading accurately and carefully. Next we are go to, this is where I don't have, let me see whether they have Vickers. Let me find out the Vickers. Rockwell impact sharply. UPN pressure test here. Upper bending test. Shear test. From the shear force bedding diagram for the supported beam is this anti-lever advantage real efficiency. Determine what will be a support, etc. No, they don't have this thing machine. So by going through their own medical manuals, we have tallied the Rockwell as well as Vickers testing machine, Rockwell as well as real hardness testing machine for ourselves, and more or less find some more information or more important question from their own documents itself. So with this thing, I am finishing our class, practical class today. Thanks for coming and patient hearing. Goodbye.